Stoichiometry, Top 50 Can A. Basics and mole ratios. 1. What is stoichiometry? Stoichiometry is the calculation of quantities of reactants and products in a chemical reaction using balanced equations. 2. Why must a chemical equation be balanced before stoichiometric calculations? Because stoichiometric calculations depend on mole ratios, which come from balanced equations. 3. What is a mole ratio? A mole ratio is the ratio of moles of substances as shown by coefficients in a balanced chemical equation. 4. From where do mole ratios come? From the coefficients of reactants and products in a balanced chemical equation. 5. In the reaction 2H2 plus O2 2H2O, what is the mole ratio of H2 to O2? The mole ratio of H2 to O2 is 2 to 1. 6. What does a coefficient in a chemical equation represent? It represents the number of moles of that substance. 7. Can mole ratios be used to compare reactants and products? Yes, mole ratios allow conversion between moles of reactants and products. 8. What is the first step in solving any stoichiometry problem? Write and balance the chemical equation. B. Mole, mass, particle calculations. 9. How do you convert mass to moles? Divide the given mass by the molar mass of the substance. 10. How do you convert moles to mass? Multiply the number of moles by the molar mass. 11. What is molar mass? The mass of 1 mole of a substance, expressed in g-mole. 12. What is Avogadro's number? 6.02210 superscript 2 superscript 3 particles per mole. 13. How do you convert moles to number of particles? Multiply moles by Avogadro's number. 14. How do you convert particles to moles? Divide the number of particles by Avogadro's number. 15. What types of particles can be counted using moles? Atoms, molecules, ions, or formula units. C. Stoichiometric calculations in reactions. 16. What is a mole-to-mole calculation? A calculation that uses mole ratios to convert moles of one substance to another. 17. What is a mole-to-mass calculation? A calculation where moles of one substance are converted to mass of another substance. 18. What is a mass-to-mass calculation? A calculation converting mass of one substance to mass of another using moles as an intermediate step. 19. Why are multiple conversion steps often needed in stoichiometry? Because calculations usually involve converting between mass, moles, and mole ratios. 20. What units are commonly used in stoichiometry problems? Grams, moles, liters, and particles. D. Limiting reactant. 21. What is a limiting reactant? The reactant that is completely consumed first and limits the amount of product formed. 22. What happens when the limiting reactant is used up? The reaction stops, even if other reactants are still present. 23. What is an excess reactant? The reactant that remains after the reaction is complete. 24. How do you identify the limiting reactant? By calculating how much product each reactant can produce and choosing the smaller amount. 25. Why is the limiting reactant important? It determines the maximum amount of product formed. 26. How does a 1-to-1 mole ratio affect limiting reactant problems? Equal moles react completely. Whichever has fewer moles is limiting. 27. What happens in non-1-to-1 mole ratio reactions? Different amounts of reactants are needed, making calculations essential to identify the limiter. 28. Can limiting reactant problems involve mass, moles, or volume? Yes, any of these can be given. E. Reaction yield and percent yield. 29. What is theoretical yield? The maximum amount of product predicted by stoichiometric calculations. 30. What is actual yield? The amount of product actually obtained in an experiment. 31. Why is actual yield usually less than theoretical yield? Due to side reactions, incomplete reactions, or loss during processing. 32. What is percent yield? A measure of reaction efficiency. 33. Write the formula for percent yield. Percent yield equals 100. 34. Can percent yield be greater than 100%? Usually no. If it is, experimental error or impurities are likely. F. Percentage composition and purity. 35. What is percentage composition?